gap space, so for my information. GNU Parallel, the first tool for today. It does one thing, it does it very well, very simply. It does not do other things. It runs many independent tasks at the same time or in series. This is the simplest tool. There is no operational setup. There's no environmental airhead or overhead. It's just a shell command. Everything we talk about later is going to do this and more. This is for embarrassingly parallel work. You've got the same command. You've got different inputs. You've got a big file with one line for every input. There's no, you don't care what order the things in. You just want to run all of them. So, parameter sweeps, those arguments. All of your tasks are independent. What you're doing can fit on a single node. GNU Parallel does not have any understanding or awareness of Slurm. It barely has understanding of other nodes via this SSH login thing. Don't use that. It doesn't work well. It doesn't scale well. Keeping those active SSH connections alive, if you tell GNU Parallel to go out to different nodes, that bit of overhead slows down GNU Parallel itself, and so your actual throughput is limited to like 100. You don't really need to track your parameter history or what happens very deeply. Like there's some logging about whether it got a task and whether it finished it or not, but nothing deeper than that and no help parsing that. It's just a text file. And whatever you're doing is simple enough that you can figure out the arrangement of your directory and file name and path organization by hand. Do you have tasks that need to finish before other tasks run? Don't use GNU Parallel. Use Maestro. Do you have more parameters than you can do by hand and keep organized? Use Signac. Do you need or want to run multi-node at the same time to get your work done sooner? Upgrade to Merlin. And do you need a history of everything? Ada. All right, first example. All right, this is what using GNU Parallel looks like. You type parallel, you put in your command line, your flags, you write a bash command, and then you pass the inputs to it. All right, yeah, let's go in and yeah, here's example one. And the only real thing to look at here, so process task, that's just a proxy for some real work. It's got a sleep inside. If we take a look at run simple, can you see the whole thing here? No, not quite. All right, lots of comments. The actual command, highlight that. Okay. That's the command. You can pipe things into parallel. You use that -J to tell it how many things to run in parallel. The actual command is here inside these ticks. So that's just running process tasks that, it's going to be in the same directory here. Sequence 1 to 20. So that's going to give you a stream with 20 lines, 1, 2, 3, 4, on and on. And the only real thing to know about parallel is the brackets here. That's where the input task piece gets substituted. So this is where the 1 goes, or the 2 goes, or the 3 goes for each piece. Yeah. So if I just run that. So we put a J2. So we're going to run 2 tasks at a time. We're on the login node. That's fine. This isn't having any interactions with anything else. And so instead of running for 40 seconds, because there's a sleep 2 inside each one, we're gonna run for 20 seconds. And that was it. Like, this is simple enough that you can write one-liners by hand and just get something done and running in parallel very quickly. There's lots of like sort of cleanup and utility things that you can do this way. Yeah. All right. Yeah, there's the substitution. You get an independent shell invocation for each line that's in your input. Piping is not the only way to put things in. There's also this colon thing, and there's an input file option for tasks. It will fill up all the cores on the machine by default. Using that default on Perlmutter login nodes might give you something unexpected because we're using C groups to protect users from other users on the login nodes. But I'm not sure exactly how that would play out. Like, you're not going to break anything, but you might get a lot fewer things in parallel than you think you would. If you happen to be in a Slurm allocation, then this environment variable is going to be populated, and you'll get something more specific to the number of jobs running parallel what you have. Yeah, login node or compute node, it's fine. Oh. Yeah, speed up now. So the whole thing was 40 seconds of work, and we did them 2 at a time, so it's 20 seconds. This many tasks is not going to use all the cores on a login node or a compute node. When you're actually using this to do real amounts of work, you want to have at least the same number. Otherwise, you're leaving some cores idle. But I've given tutorials about workflow tools before, and my perspective in the past has been running jobs in parallel effectively is the main thing we're talking about. So it was very much tools like this. And this go around, I'm trying to have more focus on like sort of the organization and the history and bookkeeping and searchability and record keeping. But this discussion right here, this is still about using the resources effectively. And it is still something that, like, from an HPC mindset and as an HPC center, we do want people to think about, like, please use the resources effectively. If you can with not too much effort, like, you don't have to go down super optimizing, run the latest and greatest, whatever, but at least put a little bit of energy in and don't do brute force for everything, because that limits the resources that can be used by everyone else. You know, we've got 10,000 users trying to share these resources and get all the science out of it that we can. So it's kind of like a good neighbor kind of thing in certain aspects. Especially think about that in terms of using the login nodes, because people running things on login nodes that are compute intensive can be a big problem for us and other users, and forces us to do like administration work and police work that we don't want to. We'd rather be, you know, helping people getting things run faster and better instead of like, you know, nagging about what people actually do on the login nodes.
There are a couple of questions.
Oh, all right. All right. So I am.
Last 3 questions.
All right. So I'm going to stop. Let's pull up the tech. All right. So I've got the chat window open. You can't see it on there, but it's here. The first command that I typed after I cd'd into the example parameter sweep directory. All right. All right, so I've cd'd in. Normally I'll do an ls just to get my bearings. So there's 3 files in there. Show them to me. I think I also, a cat. So cat, that is the command that just prints out the contents of a file. And you can do multiple files and then put them together. It's short for catname. And so I did cat, run simple. And this is just showing me the content of what was in that file. So hopefully that covers that question. I'm on a Mac, so I can do Control K, which I love to do because I want to think about one thing at a time. All right. All right. Simon Bouchard. So the brackets are replaced by some ID ranging from 0 to n, or can this be customized? Okay. So that substitution is not pulling an ID or any sort of special thing. What is being substituted is the content on the line in the input that you give to GNU Parallel. You could fill GNU Parallel with like just shell commands, like the whole command, all of the parameters you want to give it. And the substitution would be that entire string gets put into the command that GNU Parallel runs. So you don't necessarily have to be running the same command for everything. You could do a whole list of different commands if you wanted to. There's also, there's a little extra power there because there's some options for putting different characters inside. Well, let's go back a little bit so we're actually looking at, yeah. So you could put a dot or a slash in here, and that gives you some automation in doing path operations. So if you've got like, a full file path inside your input file, and you want just the file name, there's some content you can put here to do that. If you want just the path leading up to that location, there's a different character you can put between the brackets, and it will do that partial substitution. All right, Terrence Ty. In practice, if I'm submitting a bunch of embarrassing parallel jobs, how does using GNU Parallel compare to Slurm job arrays? All right, at NERSC, Slurm job arrays inside Slurm, each element of a job array is treated like its own job as far as the scheduler is concerned. The actual job array submission really is only for making the user interface to you simpler. Each piece is still its own job. And the major reason why that matters is because we have a scheduler policy that we call max job accrue 2. And the purpose of the effect of max job accrue 2 is if a user has a lot of jobs in the queue, only 2 of them actually gain priority in the queue at a time until they start running, and then another 2 gain priority to move through. And the reason for that is in the distant past, we had problems with users that would put in very, very large numbers of very small machines. And without this limitation, those jobs would come to occupy the entire system and push all of the other users off for extended amounts of time. And then we get lots of complaints, and of course we don't like complaints. So this ends up being sort of a more egalitarian approach to how people can get through the scheduling. The way to still get more like sort of volume of compute out of the machine, even though you have 2 jobs gaining priority at a time, is you want to pack lots of smaller pieces of work into fewer Slurm jobs. And that is effectively the opposite of the shape of a job array. So the suggestion here, and GNU Parallel is a great tool for doing this, would be rewrite your job array so that instead of being a job array, it's just a single Slurm submission. The Slurm submission runs GNU Parallel in it, and everything that would be an array job is instead a line that's going into your GNU Parallel that runs your individual task. And so all of those pieces are going to move through the queue together inside, under the limit of max job accrue 2, and they won't be going one at a time through the queue. Okay. VASP. I'm not, so there's a question about VASP. I see in my duties as a consultant, lots of people who run VASP and have kind of a sense of how their directories end up looking with like all those little the strings of element symbols tied together in directory trees. One of the later tools is going to be better for VASP than GNU Parallel for sure. Yeah, I guess keep paying attention. This should hopefully be something better for later. All right. Parallel Slurm job submission for multiple folders. All right. I need to parse this carefully. For parallel Slurm job submissions, so you're doing more than one SPatch command with different scripts. Okay. Modify the process task in that case. All right, so Slurm should accept different working directories if you're calling it from different places. Or there's options to set the working directory so that if you're doing work that would have name collisions, if you reran it, you can do it in different directories. There's also there are some substitution characters that you can give to Slurm that will be like, put the job ID name here, put the job step there, that kind of thing. And that will insert some unique characters into, like the name of your output or the name of something that you're passing to one of your internal arguments so that you can get distinguished file names from multiple runs of something that otherwise is very similar. Slurm CPUs on node is not defined. Only available in an active job. Okay. Slurm CPUs on node may not be defined under certain circumstances. I can't investigate that right now. Allocate more than, okay. Cara Giovanetti. Can I allocate more than one core for each job with this setup? I suspect, so HPC terminology, I'm expecting that you need more than one node. Node would be like sort of the entire allocation of a full thing that has multiple cores inside.
No, I do not mean more than one node.
Okay,
I mean
okay.
on
Actually-
a single node, can I allocate multiple cores for each task that GNU Parallel is running through?
Okay, so the way that I would do that is I would give it an explicit J number that is some divisor of the number of cores available. So if I want every job to have access to 2 cores, then I would give it J64. And 4 cores, 32, and so on and so forth. It is not a direct way to do it. Other tools have better interfaces for that, but that will give you the running effect that you want.
So it will just automatically distribute over all of okay, great, thanks.
One of the nice things about GNU Parallel approach to this is the operating system that is running on the compute nodes is reasonably intelligent about allocating resources and not like putting all of your jobs on the same core and leaving them idle. It will distribute things reasonably without you needing to pay attention to it at the single node level. All right, I should keep moving forward.
Yeah, I also like copy and paste the question and also try to answer on the answer question.
Okay, yeah, I'm gonna keep moving forward. Asian.
Yeah. Okay.
Not derogatory.
Yeah.
Okay. Combinatorial sweeps. So in the second example, you may want to have inputs that are not, it's just a line that you put in the input file, but it's some combination of things. Different materials, time deltas, temperatures, whatever conditions you may want to be sweeping through. There's a Cartesian product building of inputs possible with GNU Parallel. So here we have the parallel in the command, and we've got 3 options here, and the 3 colons are gonna do the Cartesian product between these 3 dimensions. Oh. Yeah, let's just go run that example so I can point at things directly. Run combinations. All right, so we're still going through J2, looking at 2 at a time. Now we see it's stepping through the combinations of those dimensions that we gave it. So here's O3, here's O2. Now we change the medium, and there's an O3 and O2. And down and down and down. That's something that you can do in the one-line, but exact format with the 3 colons. There are other input formats, like different numbers of colons, that you can do a file as one of your dimensions instead of explicitly typing the things here. So that's a way that you get more automation out of this than just, multiply 27 things together. Positional placeholders. Here's an example of adding some content between the brackets to get more specific behavior. You can use a number to refer to those dimensions if you want to access them specifically. So this is, if you've ever used a language that had like a $1 or a $2 notation for getting at the arguments that are coming in, this is very similar to that. And there's also the ability to add this plus sign here to get you a link thing where instead of doing the product, it's just going to do mapping them 1 to 1 to 1. So you would be doing sort of slices of your dimensions instead of the full Cartesian product. Yeah, all right. Yeah, things we're not doing. My slides are gonna have a lot of repeating of these statements about what this didn't do and what other things do. And I think I'm just gonna start sort of glancing past those because I'm repeating myself a lot. All right, so moving on to running one of these on Parameter. We're going to talk at least some about what a Slurm batch script actually looks like on the inside. Hopefully you already know this, and this is review. Single node. I will do an aside here. The nurse documentation has an example that I put together that I felt very clever about at the time because I was very enamored with GNU Parallel at the time. But I've learned more tools since then. There is a fun way to use GNU Parallel to run inside multi-node jobs. Now, the trick under the hood is that you pass in your file with all of your tasks, and it uses some bash and some awk to do a cardinal, like a round robin separation of the task into different non-overlapping sets. And then it passes each of those sets to a different node, and each node runs its own GNU parallel. It's clever, and I'm proud of it, but at this point in time, other tools are better for doing something like that. Like one of the things that you don't get for that is load balancing. If some of your tasks run much longer than others, well, that doesn't matter as far as this decomposition is concerned, because everything is fixed to what node it's going to run on, regardless of how long it takes. So it is possible to use GNU Parallel to do multi-node jobs if everything's independent. Constraint CPU, this is also the dash uppercase C CPU. Perlmutter requires this. We force people to choose between CPU or GPU nodes. The training reservation is CPU nodes only. If you put in a GPU job, I think it's just going to stay pending forever and never run. I don't think it's going to outright reject it. QoS regular, this would be the equivalent of dash Q for the short version. We also have access to debug and interactive. Time 30 minutes. If you're doing debug, 30 minutes is the longest wall clock that you can use. Hopefully 30 minutes is more than long enough for anything that we'll be doing in any of the examples. And the account, this would be where ntrain3 gets substituted, or your own like n12345 if you are using an actual nurse project allocation. All right, this %J, that's an example of one of those symbols that Slurm will substitute out for some piece of information about the job at hand, like in this case, the job ID. So this is going to give you a Slurm dash job ID number output that is unique for each job. And like that's one of the ways that you can run the same script over and over and have outputs that don't collide with each other. All right, in example 3, we're including a task list.txt, and there's 100 lines in it. And that is uses the caret to feed that into the parallel command, and GNU Parallel runs all of them inside the Slurm job. And I guess something that is much more shaped like a production use of this is your logic that's creating your list of tasks is not like a command that is directly connected to your parallel run. So you can have other infrastructure elsewhere that is actually constructing your task list and can be much smarter about what's putting things in than just like seek 1 through 20. All right, fault tolerance, this job log and resume failed. This is a very, very rudimentary feature. This is the simplest possible version of this. GNU Parallel will have this parallel job.log file that it writes, and it's just going to tell you information about where it ran, when it ran, and what the exit value was, and what it ran. Either exit code 0, it worked, or it didn't. If you run the same command again with resume failed, it's going to open that file back up, and it's going to look for everything that didn't have exit code 0. And it's only going to run those things. So the granularity of the fault tolerances at the task level, you can't save any work in a partially complete task. It just treats it as I have to start that back from the beginning. You cannot change your task list if you're doing something like this. This is undefined behavior in like the C++ sense of undefined behavior. Don't do that. It may actually technically work if you do that, but you can't count on that whatsoever. It was an accident if it did work. Yeah, and there's a simple workflow that you can put together by hand for being able to do this retry stuff on your own. Best practices. All right. Adding a tiny little delay to GNU Parallel is broadly a good idea. It's gonna help push your I/O operations apart a little bit. I/O operations on a networked file system, especially if like one application is really cramming them into a short period of time, can be a problem. In past systems, it was more of a problem for the Slurm controller, since there's like one database and one Slurm controller. So if GNU Parallel were doing some kind of interaction with the Slurm database, like doing sruns or something, that's another thing that you need to delay stagger so that you're not putting in like 300 srun commands within a few milliseconds. Yeah. Okay. Okay, limitations. This is going to be another section of when should you use another tool. Do your tasks depend on the order that they run? Don't use GNU Parallel. Do you need help organizing your parameters beyond just like setting up your own logic with brackets and substitutions and file paths? If you need a lot of that, you should use a different tool. If you need multiple nodes worth of work, you should probably use a different tool. And if you need that history to be rich and automatic and useful, then you should use a different tool. Don't run heavy work on login nodes. I touched on that. Try not to submit lots of very small jobs to Slurm. Each job submission does put a little bit of load on the Slurm controller, and if that gets overwhelmed, then that's disruptive to everyone using NERSC resources. We really do want people to find ways to pack lots of small tasks into fewer, larger jobs and submissions. And if you want to try and fake having some kind of task dependency by using like backgrounds and weights and some other kind of bash stuff to organize your parallel, just use Maestro instead. Oh yeah, and SSH login. Don't use SSH login. It is kind of flaky. Use Merlin instead.